Hello everyone. So today we are going to solve balance tree check. This is the I guess seventh video of this playlist. If you have not watched the previous videos, I would highly recommend to watch these videos so that you will be updated with the which approach we are going to use. So let's see this balance tree check. What the problem is saying is, so we have given a binary tree and we need to identify if this binary tree is the height balanced or not. What do you mean by height balance? Height balance means if the absolute difference in the height of the left and right subtree is at most one for every node in the tree. Okay. So let's consider one example. Consider this is the one, two, three, four, and five. I would highly recommend to watch the at least if you have not watched height, how to find the height of the binary tree. If you know, it is better. If you don't know, please watch that video so that it will be very helpful in this particular example. So consider this is a example we have given, and we need to check like what is the height balance. Is this height balance tree or not? Okay. So what is the height balance? Height balance is nothing but we need to find the height of the left and right subtree, right? Then we will do the same thing as the problem is saying. Consider I am at the root level, okay, and I will find the left subtree height that it is saying. So finding the left subtree height, we will find out because we have seen, and consider this height of the right subtree, and we will check. Consider this is something LH left height, left tree height, and consider this is RH right tree height, and we will check if that difference is at most one or not. If this absolute difference is at most one, we are good. But if it is not, then it means this is not a height balance. Then we will just return the false. But if for this particular node, if consider this for particular node, this tree is the balanced tree. But for the particular internal node, this might be possible. Example, consider we have something one, two, three, and four. Consider five and six. 3 minus 2 is 1, and consider 7. Okay. So for this one node, what is the left height? Left height is 3. Okay, 3. Right height is also 3. So we will return 0. So it means it is at most it is less than 1. Okay, less than 1, less than or equal to 1. So we will say this is the height balanced for root level 1. But what about this node? What about this? We don't even need to we don't only need to check for this. We also need to check for internal nodes. For 2, what is the left height? Left height is 2, but the right height is 0 only because there is no null node. So it means for this one, 2 minus 0 is greater than 1. So it means this is violating the conditions, and we will say this complete tree is not height balanced. Even for this particular root node, the height is balanced, but for some one of the internal node, the height is not balanced. We will say the complete tree is not a height balanced. So the same, we will write this like in the code format also. If root is null, okay, if root is null, then I will simply say my tree is height balanced, because if there is no node, there is no point of the discussion like it is balanced or not. If my root node is the leaf node, okay, these are the basic conditions that we are adding so that our test cases will be easily figured it out beforehand only. Okay, if root is the leaf node, then it means it is also height balanced because there is no left and right child concept here. But if the problem is expanded to further, like if there are left or right child or both are present, then we will say we will calculate the left height tree. So left height, consider this one, and we will call one height function that will give us the height of this binary tree of the left subtree, and we will calculate the right root dot right, and we will just say if my left height that I have calculated, absolute difference we need to find out. So I will use a math library, left h minus right h. If it is greater than 1, it means this is violating our condition. So we will just return the false. But if it is not, it means we need to check the balance tree for the, if this is balance tree for left part or not. So it means both should be balanced. If both part also balanced and root level is also balanced, it means the complete tree is balanced. But if any one of them it is not balanced, it means complete tree is unbalanced. Okay, let's quickly write the height function also. Private int height of node root. So we will just write the base condition. If my root level is itself is node, then there is no height concept. But if my root node is the leaf node, then it means this will contribute height as a 1 to the parent binary tree. And otherwise, we will just say for the further node, mat dot maximum of the height of the left subtree, that is root dot left, and height of the right subtree. If you don't understood this, I would recommend you to watch the video of the how to calculate the height. Okay, so like this, we will calculate the height of the left and right subtree. So let's try to submit this. It is working. Okay, and for this, yeah, it is working. But the problem here is for every node, what we are doing is we are calculating the, let's say on the whiteboard, for every node, we are calculating the heights of the left subtree, right subtree. Then we are checking. For then again, for every two second node, we are checking the height of left and right. Again and again, we are doing the same iteration. So for the n number of nodes, consider the our tree contain n number of nodes. So we are doing the big of n square operation because n operation is for the iterating over all of the nodes and further an operation to calculate their height like each and every time. So we are doing here the big of n square, but this code is acceptable here. But we will see the optimization big of n approach that will help you in the interviews, like because interviewer will not be happy with this big of n square. So let's see what how the approach will look like for the big of n. So here what we are doing here is, let's reiterate it. We are calculating the height of each and every part again and again, right? We are calculating the height for each part again and again. Consider if I will do in a single iteration, we are not going to consider I have something example 2, 3, and 4 and 5. Consider this is the example and 6. Okay. So if my like if we will do the iteration at the like same time when we are iterating over the, we are not going to calculate the height function again and again. So consider starting from the left node 6. Okay, what if left node is null, right node is null, then we will say this is good to be like there is no height concept, so we will return the 0. Okay, for 6 node it means it is saying left height is 0, right height is 0, and we will check difference is less than 1, it means we are good. Okay, but it will return to the parent node that is 1 because this height will be contributed to the parent node. Okay, so 6 will contribute like this math plus max of left height and right height. This will be contributed to the 3 nodes so that it will identify what is the maximum height of its child subtree. Okay, before that what we are doing is we were calculating for every subtree. Okay, now we are passing this value to the parent node so that we don't need to calculate it again. Same for the right subtree. Right subtree is null, so it will return the height of the 0. It will check 1 minus 0 is less than or equal to 1. We are good here. And it will return 1 plus maximum of this. So 1 plus maximum of 1 of 0, that is 1. So it will return 2. What it is 2 is saying the height of the this tree is the 2. That is it's 3 and 6. Okay. But here the null node is present, that will return 0. So 2 minus 0 is greater than 1. It means this is violating the condition. This is violating the condition. Because for 2, the left height is the 2 and the right height is the 0. So it means this is violating the condition. This is not a height balance and we will just return the false from here directly. But if that is not the case, consider here we have a node and it will return also 1. So 2 minus 1 is it fine. So we will return the like 1 plus maximum of 2, 2 comma 1, that is 2, 2 plus 1 is 3, that we return to this. And similarly, we will check for this one. So like this, you can understood, we are not going to calculate the height and each and every time. We are just returning the height to the parent node so that once we are checking, you can understood something like this. We have a grandparent, parent, and children. First, children is validating is this height balanced or not. If this is height balanced, it will return the height for to the parent, so that parent will calculate like what is the in between among of their childrens, what is this height balanced or not. And similarly for the grandparent. So similarly, we will optimize this code only. If root is null, then we have to don't need to. If root is leaf node, then it means it is again left return true. Otherwise, consider because we need the integer function to return the height. So we will what we will do is we will just wipe off this code and we will calculate something like consider we have function is balanced and we will pass root node and we will check like this function will be considered as int. So we will pass this function only. And what we are going to do is we will check if root is null, then it means we will return 0. Okay, because there is no for that particular. If root dot left is null, leaf node basically. If leaf node is there, then it means this will contribute to 1. Okay. If you will not add this particular condition, it will also fine because this will help you in calculating that part. Otherwise, what you will calculate left edge, left height of the tree that is balanced of, I would say root dot left and int RH that will calculate is balance of the root dot right. Okay, because it will calculate the value for this particular part. Okay, so it means if the left edge and right edge we have calculated, that is balance of the root and left, and we will just see if my left edge is the balanced. It means if the left edge is balanced and right edge is also balanced, and whatever the value it is giving. Okay, so consider I am checking if left edge is not equal to -1. I am going to depict with the -1 values if it is violating the condition. And if left edge is also not equal to -1, and we will say if the absolute difference of left edge minus right edge is less than or equal to 1, it means I am good here. If I am good, so I will return the math 1 plus maximum of left height and right height, right? That we have calculated till now. We will return this. If this is violating the condition, then we will just return the -1 so that it will trace the -1 and it will return the false. And we will check if it is balance of root tree is greater than 0, it means we are good. Otherwise, we have already violated the condition and we will return the false. We don't require this part of the code. Okay. So like you will understand this. Consider this is 6. It will check for the 0. It will check for the 0. It will see if this is particular, like this is balanced. It means it will return the height 2 is the parent node, and parent node will check again. Okay, if any here where we are violating the condition, we will just return the -1, because this will be going further and further to the grandparent. It will finally reach to the grandparent. It will check if the value is less than or equal to 0. It means we have violated the condition and we will return the false, because it means that tree is not balanced. Okay, so let's try with some more input. Consider we have only leaf node. Consider this example. So 3, 2, we will create some type of, like consider 10, 20, 30, 40, and null, null, null. Consider 50. So this tree is the unbalanced at the 20 level, because 2 height is there and 0 it is. Okay, let's try with this as case. Yeah, it is working fine. Let's try to submit. Yeah, so here we are calculating the height while we are doing the recursion, so we don't need to do explicitly, and this is the big of an approach. So we are, because we are iterating this as the only at the single time. Okay, so if you understood the problem, please like and subscribe my channel. It will be very helpful and motivating for me to keep continue. And thank you for watching this video.